Hello everyone. Now we discuss about the last case of a concave mirror, and this is the last and final case where we are going to place an object between the principal focus and the pole of the mirror. That is the last case, principal focus. And we started from the far off distance called infinity, and we go on keeping the object in different locations, and finally we reached very close to the concave mirror, and here the object is between the P and P pole of the mirror and the principal focus, in between the P and F of the mirror. And with the help of a ray diagram we are going to find what are the specialities of image formed in this case. Okay, so this ray diagram will tell you the characteristics of image formed by a concave mirror if an object is placed between P and F of a mirror. Okay, look at the board. And here we have a concave mirror with the aperture mm dash. P is the pole of the mirror, F is the principal focus, and C is the center of curvature of the mirror. And here see where the object is placed between P and F. This is P, this is F. And here AB is the object placed between P and F. A is the top of the object and B is the bottom. Hence A is having an arrowhead pointing upwards. Okay. So here also we are going to consider two incident rays to study about the image formation. But a small difference here, I am going to consider a ray that makes some angle with the principal axis. I can consider any type of incident ray. Here the incident ray makes some angle with the principal axis. So this is the incident ray making some angle with the principal axis. So what will happen to this ray after reflection? That ray will get reflected from the point by making same angle of reflection. So this angle, how much angle is made by this incident ray with the axis? The same, that the reflected ray will also make the same angle with the principal axis, or these two angles will be equal. So this is the incident ray, this is the reflected ray. So this is first incident ray and this is the second first reflected ray. So let me name it PM. AP is the incident ray and PN is the reflected ray. And secondly, I need to consider one more ray to find the second reflected ray. So this second ray, it passes through the center of curvature of the mirror, passes through the center of curvature of the mirror. So this is the ray passes through the center of curvature of the mirror, strikes the mirror at this point and get reflected along the same point in backward direction. Clear? So first incident ray, first reflected ray. Second incident ray passes through the point C and it gets reflected along the same path in opposite direction. So these two are the reflected rays. First reflected ray, second reflected ray. But these two are divergent in nature. They are diverging. So they are not parallel. They are diverging rays. They are not going to meet at a point near to the concave mirror or even at a far off distance infinity. So never they meet each other. So we are not going to get a real image because these reflected rays are not going to meet at a point. So we are here no chance to get a real and inverted image in this case. So here what we do is we will produce the reflected rays backwards to find the correct point where the image will be formed. So here we are not expecting any real image because really the reflected rays are not going to meet at a point. So we are not going to get a real image. Instead of that we will get a virtual and erect image in this case. This is the only one case where we are getting a virtual and erect image from a concave mirror. All other cases we got real and inverted, but only in this case we are going to get a virtual or not really existing, or the image that is always erect and the size will be larger than the object, not highly enlarged but just larger than the used object. Okay, so here these two are reflected rays but they are divergent, so no way I'll get a real image. So what I want to do is I want to just produce the reflected rays backwards to find the image formation. So I am producing these rays backwards, just producing these rays backwards. This is first reflected ray, first reflected ray backwards, and this is the second reflected ray. I produce these two reflected rays backwards. So these two reflected rays, on producing backwards, these two meet at a point A dash behind the mirror, or in phase with the non-reflecting side of the mirror. Here the point of convergence is behind the mirror, not in front. In front means we will get real and inverted image. If two virtual rays are meeting behind the mirror, means there we are going to get a virtual and erect image of the object. Here we use dotted lines to produce, when we produce the lines backwards or rays backwards, we should draw the dotted lines. This dotted line shows that these rays are not real, they are virtual rays. Virtual. Whenever we draw real rays, we should use solid lines to denote it. But whenever we draw a virtual image, we should use dotted lines to present it or represent it. Okay. So this is the point of intersection of these two reflected rays. Clear? That is not a real point, that is virtual point, and here the point is lying on the above the principal axis. To get the complete image, we drop a dotted line, because it is virtual one, dotted line to the principal axis. This is the top. So here I am marking a point, arrowhead on the top, A dash, and here this point is B dash. So A dash, B dash is the image formed. Clear? So in this case, all the things are same as that in all other cases, but only one difference, we are getting a virtual image. So you can see some dotted lines here and here. So this dotted line shows that these rays are virtual in nature, and the image is also virtual in nature, because their image is not really existing. That is an illusion, or that is simply an assumption or an imaginary one. So we will never get an image back of the non-reflecting side. Okay, that is true, because we will not get any type of image behind. But when we look from this side, the A dash, B dash appears to be formed behind the non-reflecting side of the, or in phase with the non-reflecting or behind the reflecting surface of a mirror. A dash, B dash is a virtual one. That is why we used some dotted lines to show the size of the image, as well as show the rays on producing these two reflected rays backwards. So we use dotted lines here and here. Okay. So this is the place where we are getting an imaginary or virtual image of the object AB placed between P and F of the mirror. And this image is, what is the position, what is the size, and what is the nature of the image. What is the position? Tell me. What is the position of the image formed? Behind the mirror. Behind. The image is formed behind the mirror. Right? Image is formed behind the mirror. What is the size? Or enlarged. Enlarged image. Or greater, or the size is greater than that of the object. And what is the nature? Virtual. V stands for virtual and E stands for erect. So this is the case, only one case where we are getting a virtual and erect image of the object. All other cases we got real and inverted. Size can be same or lesser than object, or greater than the object. But here in this case, when we place an object between P and F of a mirror, we got an image that is enlarged one, not highly enlarged. Highly enlarged only in the case where we keep an object at F of the mirror. But here enlarged or larger than the object, and it is virtual and erect, and it is, the position is behind the mirror or back of the mirror. So back means we will never get a real image on back side of the mirror. That is virtual. That is simply an assumption or just an illusion. When we look from this side, the image appears to be there behind the mirror. That is the meaning. So with this we completed all the cases. So what you want to do is, you have to chart out all these different positions of the object and nature, position, and what size of the image formed in different cases. So draw a tabular column and write all these details into your notebook. So with this we completed all the cases of a concave mirror, and next we will study about the cases of a convex mirror in detail in the next class. Okay, thank you very much.